I would like to double check it. What I noticed in how you calculated it is that you kind of went like you learn one thing and then you think, okay, I'll just use it for everything. And while law of sines does work here, it's a right triangle. So the sine, just doing the plain old sine of 68 equals the opposite over 9. It's probably a faster approach here, better approach. You want to save law of sines and law of cosines for non-right triangles, even though it does work.
Okay.
I actually saw I had another student I'm helping, and they did the same thing. And I mean, I find that really odd. I mean, are they telling you in class to do that? Or are they saying, hey, go ahead and use law of sines now for everything?
No, but it's just like, I don't know. Yeah, I don't know.
It does work. Like it's not wrong. And it's just like you don't want to, do something that's harder than it has to be. Like when I do baking, I use the hand mixer or the one on the counter. I don't whisk it by by hand. Yeah,
Yeah.
you want to find the best path there. So let's just say that's right. Then you've got it there. You find the height. Now, do they give you? They do not give you, or they do give you the base. So you do have base times height. You got it. All right, fantastic. On to number 2. So there's nothing wrong with your answer. I just wanted to comment on my procedure there. All right, calculate the area of the trapezoid. The area of a trapezoid, sometimes it's good to start with the formula. A lot of different ways it can be written. Base 1 plus base 2 divided by 2 times the height. You have base 1, but you do not have base 2. You partially have base 2 because it's related to down here. But you have to find a couple things. You have to find I'll call this X from the right triangle. And then you also need to drop an altitude here and find some other things, which I don't know. I'm sorry. No. Yeah, you do need that because you don't have, oh, these are parallel. That's good. So it looks like you need to find this little length here.
Okay.
I'm not sure how, oh, you do have one of the sides, but you don't have one of the angles. Sorry, I'm just kind of looking ahead here. 93 degrees. Okay. So that's 90, that's 90. Interesting. Okay, it's like you didn't, I guess this is a good question. We're gonna have to find some information on this triangle, but let's find X first. That's the easiest path to go down here. Let's use this is actually Pythagorean triple. So if you don't see it, you have to use a squared plus b squared equals c squared. X squared plus 30 squared equals 34 squared to find X.
Okay.
So if you could do that for us, please, appreciate it.
Yeah. Um, 16.
It's 16. Good. Okay. All right. So we're well on our way here. Unfortunately, again, like we've got to look at this triangle over here, and we really need an angle. Okay. And we probably are best, are best going to find kind of this one here in the corner. And the way we're going to find that, I'm going to redraw the trapezoid here. To find this angle down here in the lower left, we have to find How are we going to do that? Huh. I'm struggling here because I'm trying to figure out how we're going to figure out, we need to figure out one of the lengths here. It's not, it is 42, but we need this part and then we need this little part here. If you drop this straight down. Okay, I guess that is, okay, that is enough there. I now see what they had in mind here. So the whole angle up here, the whole angle is 93. When you drop down the vertical, it tells you that the angle in here is 3 degrees. Because the sliver angle right there.
Oh, okay.
And that allows you to find, I'll call this B down here. The tangent of 3 degrees equals B over 30 centimeters here. And that allows you to quickly find B. B is 30 tangent 3. So if you got a calculator handy, go ahead and calculate that for us, please.
Yeah.
It's not very big, but go to like 2 decimal places for that.
1.57.
Okay. And now we finally have it. So the top is 42. The bottom is the 42 plus the 1.57 plus the 16. Now you've got your B1 and your B2, and your height is 30. And now you can use the trapezoid formula to determine the area there.
Okay.
So go ahead and do that. I've got, I'm going to do the same. See here. I do have the result here. Let me know if you have any questions on the calculation.
Okay. Is it 1,523.55?
Yes, very good. And then centimeters squared.
Centimeters squared.
You've always been really good at the calculations. It shouldn't, sometimes get biased because of working with other students that aren't as good. So that's fantastic. Yeah, kind of tricky. I was about to go down a really interesting road, but they have to give you enough information to find it. Like you can't, there's only so many things you should have to do to be able to determine it. But
Yeah.
all right. Here we go. Number 3. Does this typically resemble your test? Like, do you get problems like these, or are they just totally different when you see the test?
Yeah, some of them are like these.
Okay, that's good to know. All right. So what's interesting about the trapezoid is this median, kind of this midline. It's the average of the bases. Now, I know you can use the formula, but you can also think of it as like a jump. Like if you subtract 3, you will also subtract 3 to get to 15 centimeters up here. Or similar, if you're like, hey, I want to add 3, you can add 3 to get here. Does that
Okay.
make sense?
Yes.
Okay. All right. Now, sometimes you got to kind of like make a leap of faith here with a few things. Like you really want to find the height here. or you want to find, I'm sorry, you actually want to find this outside one. Oh, there it is. Okay, that's key. I was like, why? How do we not know what it is? Okay, so since it's an isosceles trapezoid, that means that the triangles on the left and the right are congruent. That means this is 15 here, and it's split between the two, so that's 3 and that's 3. That allows you to find the height, which you actually don't need because you're trying to find the perimeter or the hypotenuse. Okay, so here it's the cosine of 71. The reason it's cosine of 71 is you have the adjacent and then you want the hypotenuse. That's 3 over h. And then you have to solve for h here.
Okay.
So let me know if any questions on that, but I think you can handle that. Once you get h, you double it, you add the other two, and you get the area of the perimeter in this case.
H is 0.98.
Oops, some sort of error here. So a couple of ways to do this on the right. To get the variable out of the bottom, you can multiply by the variable, or you can flip the fractions on both sides, or you can cross multiply. Do any of those sound familiar to you? One you like more than another?
Cross multiplying.
Okay, so that's h cosine 71 equals 3 times 1. And then you divide both sides by cosine 71.
I just plugged it in wrong.
Okay, that isn't also a common thing. I've done it a lot. All right, so what do you have?
9.21.
Yes, and then go ahead and find the perimeter.
Um, 165.78.
Perimeter, right? Perimeter, we're just adding up the four sides, the 15, the 21, and then 2 h's.
I did area. Oh my gosh.
That's okay. That's a common thing here. If
Because
it were
I was
multiple choice,
thinking,
but
sorry, I was thinking H height.
yeah, and that's my fault. I mean, I was thinking, well, you're probably going to find that, but you don't.
Okay, 54.42.
All right. So any thoughts on that? I mean, you know a few you don't know a few formulas, probably get more familiar the more we do. One more trapezoid problem, it looks like. This one is area. All right. The nice thing is you have the base 1, you have base 2,
Mhm.
and you have the height. Or actually, you don't have base 2. You can calculate base 2, but you have the height. So you almost have everything. Like that's a good thing. Sometimes it's a good idea to kind of draw what you have here. Um, so this one is not a right triangle. So what can you do to find the opposite side when you don't have a right triangle? What are the two possibilities? This one, you've got a side, an angle, and a side. Does that,
Yeah, okay.
you remember which one that is? Is that law of sines or law of cosines?
Love cosines.
Law of cosines, good. And there's a bunch of formulas for it. I try not to get too caught up in it. The formulas themselves, you're finding the side across from it. Okay, so we're gonna call that c squared. So think of the side across that we're trying to find as c squared. And then the other two sides are a squared and b squared. So this looks a lot like the Pythagorean theorem right here.
Right.
Minus 2ab, to notice that these two letters are the same as the ones on the right side here. That's always the case. Cosine of the same corresponding angle as the side we're trying to find. So there's kind of a mapping to these formulas. Like you don't have to necessarily like remember them. You have to just know why letters go in certain places.
Yeah. Okay.
All right, so in this problem, it's x squared equals 20 squared plus 55 squared minus 2 times 20 times 55 cosine of 64.
Okay.
So the calculation on the right's not too bad. Just putting in the calculator, you have to remember that to take a square root.
Okay, right.
So go ahead and calculate that. I'm sure you'll get the right answer. But always good to do the calculations. Always good to double check me.
Mm. So, should I do? Okay, I have x squared equals 1225 cosine 64. Should I do the cosine and then do the square root?
I would put all of this in the calculator. I mean, the calculator would do all this, and yeah, I didn't. If you could multiply by the cosine of 64, we could tell you whether your answer is right. Although these numbers are attached to the cosine, so it's like you have a number times cosine that you're subtracting. Like I would just put this all in. That
Okay.
would probably be an easier way to.
Okay,
X squared is a pretty large number.
is it 2,460?
Yes. Very good. And then you have to take a
Square
you have
root.
to take a square root of that, yeah.
49.6.
Yes. Okay, it feels like we've done a lot. Like it's like, are we done? No, we're not done. That's just base 1 or base 2, depending on how you're looking at it. So I mean, I have the advantage here where I can just grab it and kind of reframe the problem here. We got 49.6. So the area of the trapezoid here is base 1, 49.6 plus base 2 divided by 2 all times the height, 19.
Okay. Okay, 1,088.7
All right, sounds good. What are the units of that?
centimeters squared.
Perfect. All right, I think we're kicking the trapezoids down the road. Looks like you've already done part of 5, maybe all of it. You feel like you have it, or do you want some more explanation on that?
I think that one was good.
Okay. All right, number 6. All right, calculate the area of a regular nonagon. Regular nonagon. So the nonagon is 9-sided. That's kind of important. We'll get to that. We can do this a couple of ways. So there's this formula 1/2 the apothem times the perimeter. Have you seen that?
No.
All right. So the apothem is the distance from the center kind of out to the base, I guess.
Okay.
So if we find this, we're in good shape. But we also need the perimeter, which means we need to find the length of each of these sides. I feel like you've never seen a problem like this before, just based on kind of what I'm hearing. Is
Yeah, I
this
haven't.
completely new? Okay.
Yeah.
All right, fair enough. There's a lot of steps here. So the first thing is actually to figure out the angle of each of these. You wouldn't even know to do that, but that comes from the sum. The sum of a nonagon, a 9-sided polygon, is 9 minus 2 times 180. There's a formula n minus 2 times 180 to get the that's on there. So could you calculate that for us, please?
Yes. 1,260.
Okay. And then because you don't really want the sum, you want the actual angle measure, you divide it by the number of sides. Excuse me. Let me know what you come up with for that.
140.
140 degrees. So this angle over here is 140 degrees. And if you cut it in half, that makes this angle 70 degrees there.
Okay.
So regardless of whether we're using this formula or another formula, you have to find the angle so that you can find the X and the Y, or the A and the B, if you will. All right.
Yeah.
Will you calculate X and Y? You're going to use sine, cosine, tangent to do that, please.
Okay. Mm, Um, I think I did it not right. Is Y 11.28?
All right. So Y, yeah, you got Y correct. So do the same thing for X.
Is it 10.6?
For uh for Y, you use sine, right? Y, and you can bring 12 sine 70. X is going to be 12 cosine 70. Or you could use Pythagorean theorem. Maybe, yeah, I guess different side. I would probably just stick to trigonometry.
Okay. So then 4.1.
Yes. Very good. So the fact that you've got those two values makes the problem a whole lot easier. So now we can actually talk about like how to do it. So you've got I'm not going to draw it differently here. You've got this kind of triangle here where X is the 4.1, but if you double it, it's 8.2. And the height is 11.3. So there are two ways to proceed. One is to find the area of this triangle and then multiply by 9 because there's 9 of them. Or you can use this formula, which is essentially the same, but um, you got to kind of decide, do you think it would be better for you to find the area of a triangle and multiply by 9? Or do you want to try and use this formula here? It's the same.
I think the area of just one of the triangles.
Okay. So area of one of these triangles is base times height divided by 2. And so the total area is 9 times one of those triangles.
Okay. Okay. Area is 416.97.
Sounds good. Meters squared.
Meters squared.
All right. All right. So the next problem here is some sort of a circle thing. It's a slice without the crust, maybe. Not quite sure. Let me take a look here. Calculate the area of the segment of circle M. Do they mean the triangle or the crust or
Segment. Maybe the like darker part. I don't know.
okay, the shaded part? That's fine. We just have to, we just need to know. So to find, it's the pizza crust, or I'm sorry, the pizza slice minus the triangle.
Okay.
So we find the area of the pizza slice. Hopefully you've had pizza before and you're not shocked here about this. And then find the area of the triangle, and then you have it.
Okay.
So the area of the pizza slice, that's a pretty well known formula. It's the angle at a 360 pi r squared. And you have to say, okay, well, do you know the radius? And yes, you do. To find the area of the triangle, a little bit more complicated. There's a couple of options here. You can use a formula when you have side angle side. There's a given formula for that. Maybe you've seen it 1/2 AB sine C. Does that
Yes.
look up? Okay. That would be the best. The other options involve like dropping an altitude, using some trigonometry to find the height, doubling it. This is a little bit better.
Okay.
All right, so let's go ahead and start calculating here. So on the left here, it's 74 out of 360 pi 13 squared minus 1/2 13 times 13 sine 74. And your calculator can do all this together. Like you don't have to try to separate it.
Okay. Okay, 27.9.
Is that your final answer?
Yes.
Okay, let me, I was calculating intermediate ones because I didn't know how you were going to do this. So let me get caught up. That looks right. You said 27.9?
Mm-hmm.
Yes, that's correct. And no, and for whatever reason, no units of measure. But that's what we can do about that.
Right. Okay.
All right. Okay. Number 8.
Okay.
Okay. Area of the rhombus. So interestingly, rhombus and a kite share similar area formulas. It's 1/2 diagonal 1 times diagonal 2. Not sure if that's relevant here. We can also use the base times height formula, depending on the problem. But one thing we've got to do here, well, it might be obvious here, but all the sides are the same. I don't know if that helps here, but all the sides are the same. So the reason that helps is if you draw this diagonal, and we'll call that diagonal 1, you can calculate diagonal 1 using law of cosines. But you can also just use that 1/2 AB sine C for this.
Okay, right.
And that's probably better because the triangles are actually congruent. So if you find the area of the top triangle, 1/2 66 times 66 sine 118, you can similarly double it to find the area of the other. It feels a little bit like we're doing a shortcut here. I mean, you could do this a couple of other ways as well. I mean, you could literally find diagonal 1, then you could use another kind of a related formula to find diagonal 2, and then use this one.
Is it 1923?
That's the area of one triangle, and if you double it, you'll get the area of the other.
Okay.
That's actually kind of the idea behind the kite as well, is you can find the area of one triangle and double it.
So then 3,846.12
Yeah. And we got some units here.
millimeters squared.
Yeah. Millimeters squared. All right. Good job. I mean, do you feel like your test will be really similar to this?
Yeah, I do.
Okay. Any problems here you feel like you like, when you see the steps now, do you think there's anything that you would need a reminder on? I mean, we did use a bunch of formulas today. I mean, over those, I don't know, you kind of know what to expect. You see, I don't think you get a formula sheet on this.
We still do, yeah.
Oh, you do? Oh, fantastic. Okay. So hopefully some of the more obscure ones like this AB sine C is on there. I think we did law of cosines at some point. Although
Yeah.
truthfully, like here, you could have found the area of this triangle. There's actually a bunch of ways to do it using that AB sine C. Then the other triangle up here is a right triangle, which I guess you would need. Oh, and then you can use base times height to find that. So there's actually a couple of different ways to do it. We may have like made some more complicated than we need to compared to others.
Yeah. Okay.
All right, was there anything else you'd like to cover today, Gracie?
No, thank you.
All right, I'm gonna go ahead and stop the